For most of the 20th century, Pluto was the ninth planet, a small, distant world at the edge of the solar system, cold, dark, mysterious, but still part of the family. Children learned its name in school. Posters placed it after Neptune. Textbooks called it the final planet. And for decades, nobody questioned it. Then, in 2006, everything changed. Astronomers gathered to decide what a planet truly is. And in one vote, Pluto lost the title it had carried for 76 years. It was no longer the ninth planet. It became something smaller, a dwarf planet. But the story is not as simple as people think. Pluto was not killed because it was boring. It was killed because scientists found other frozen worlds beyond Neptune, some almost like Pluto, some even challenging its place completely. Suddenly, the solar system was not 9 planets anymore. It was stranger, messier, and far more mysterious. Tonight, we travel back to the day Pluto was killed and ask what really happened to the little world we refuse to forget. Before we begin, if you enjoy calm, cinematic space documentaries made for sleep and deep cosmic mysteries, make sure to subscribe to Theories Before Sleep. On February 18th, 1930, in a quiet observatory in Arizona, a young astronomer noticed something moving. It was not bright, it was not dramatic. It did not blaze across the sky like a comet. It was only a tiny point of light, almost lost among countless stars on a photographic plate. But that small moving dot would change the way humanity understood the solar system. The astronomer was Clyde Tombaugh. He was only 24 years old. At Lowell Observatory, he had been given a difficult and almost exhausting task: search the sky for a possible 9th planet. Night after night, he photographed sections of the heavens. Then he compared images taken on different dates, looking for anything that shifted position against the fixed background stars. Most of the time, there was nothing, just fields of stars, thousands of dots, cold, silent, unmoving. But Tombaugh kept looking. He used a device called a blink comparator, which allowed him to switch rapidly between 2 photographs of the same region of sky. If an object had moved between the 2 images, it would appear to jump back and forth. And then he saw it, a tiny dot, moving, not a star, not a smudge, not a mistake, something real, something distant, something orbiting the sun beyond Neptune. In that moment, Tombaugh had found what many people believed would be the 9th planet of the solar system. Imagine the quiet of that room, the photographic plates, the careful comparison, the young astronomer realizing that the tiny point before him might be a world, a place no human eye had ever recognized before, a planet so far away that sunlight needed hours to reach it, a world orbiting in darkness, near the edge of everything familiar. The discovery spread quickly through the astronomical community. After years of searching, after predictions, hopes, errors, and expectations, humanity had found a new member of the planetary family. The solar system had expanded again. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and now, Pluto. The name came from an 11-year-old girl in Oxford, England. Her name was Venetia Burney. When she heard that a new planet had been discovered, she suggested the name Pluto, after the Roman god of the underworld. It was a perfect name for a world so far from the sun, hidden in the cold darkness beyond Neptune. The name also began with the letters P and L, which quietly honored Percival Lowell, the founder of Lowell Observatory, whose search for a distant ninth planet had helped lead to the discovery. And just like that, a schoolgirl gave a name to a world. There is something beautiful about that. A planet discovered by a young astronomer, named by a child, welcomed by the world. Pluto became more than a scientific object. It became a symbol, the final planet, the farthest planet, the small, lonely world at the edge of the solar system. For generations, Pluto completed the list. 9 planets. The number felt right. There was something satisfying about it. A complete family arranged outward from the sun. The inner rocky worlds, the giant planets, the distant ice giant Neptune, and then Pluto, small and strange, closing the sequence like the final word in a sentence. Children memorized it in school. My very educated mother just served us 9 pizzas. The last word was Pluto, the last place, the last stop. In classrooms, Pluto appeared on posters. In textbooks, it was drawn as a tiny dot beyond Neptune. In models of the solar system, it was placed at the edge, often so far out that the scale became impossible to show properly. But children remembered it, maybe because it was small, maybe because it was far away, maybe because it seemed like the underdog of the solar system. Jupiter was massive, Saturn had rings, Mars was red and close enough to imagine visiting, Venus was bright, Earth was home. But Pluto was different. It was the little planet in the dark, the one that lived alone, the one that seemed almost forgotten by the sun. And because of that, people loved it. Pluto entered culture in a way few astronomical objects ever do. It became part of memory, language, childhood, imagination. It appeared in science books, cartoons, classroom walls, planetarium shows, and conversations about space. To millions of people, Pluto was not just a distant icy body. It was the 9th planet. That identity lasted for 76 years. From 1930 to 2006, Pluto belonged to the planetary family. But even in the beginning, Pluto was unusual. It was always the strange one. Its orbit was not like the others. The major planets orbit the Sun in relatively orderly paths, mostly close to the same flat plane. Pluto's orbit was tilted. It was stretched into an ellipse. At times, Pluto came closer to the Sun than Neptune, though the two worlds would never collide because their orbits are locked in a stable rhythm. That alone made Pluto different. Then came its size. For decades after its discovery, astronomers thought Pluto might be much larger than it really was. Early estimates were uncertain because Pluto was so far away and so difficult to measure. Some imagined it might be comparable to Earth, or at least large enough to explain supposed disturbances in the orbit of Neptune. But as telescopes improved, Pluto kept shrinking. Not physically, of course, only in our understanding. It became clear that Pluto was far smaller than expected, smaller than Earth, smaller than Mars, smaller than Mercury, even smaller than Earth's moon. The 9th planet was not a giant hidden in the darkness. It was a tiny frozen world. And yet it remained a planet, because for most people, size was not the point. Pluto had been found. Pluto had been named. Pluto had been accepted. Pluto had a place. Then, in 1978, another surprise came. Astronomers discovered that Pluto had a large moon, Charon. This changed everything again. Charon was unusually large compared with Pluto itself. In fact, Pluto and Charon are sometimes described as a double system because they orbit a center of mass outside Pluto's surface. They are locked together facing each other across space, like two frozen companions at the edge of the solar system. This made Pluto even more fascinating. Not just a lonely world, but a strange little system, a dwarf-like planet with a giant moon, a cold double world turning slowly in darkness. Later, more moons would be discovered: Nix, Hydra, Kerberos, and Styx. Pluto became not just a point of light, but the center of a miniature family. But in the wider imagination, it was still simple. Pluto was the 9th planet, small, distant, mysterious. For most of the 20th century, nobody had seen Pluto clearly. Even the best images showed little more than a blurry point. It was too far away, too small, and too dim. We knew it existed, but we did not truly know what it looked like. That mystery helped protect its magic. Pluto was a blank space for imagination. What would the surface be like? Would there be mountains, ice, craters, a thin atmosphere? Could the sun even look like a sun from that far away? In reality, from Pluto, the sun would still be bright, but it would appear much smaller than it does from Earth. Daylight there would be weak and cold, like a deep twilight compared with our world. The surface would be frozen. The sky, if the thin atmosphere were present, would be faint and alien. But before spacecraft reached it, Pluto belonged partly to science and partly to dream. It was the planet nobody had visited, the planet nobody had mapped, the planet that waited at the far edge of every classroom diagram. And that made it powerful. There is something about distant worlds that captures human imagination differently. Close worlds invite exploration. Distant worlds invite wonder. Mars feels like a destination. Pluto felt like a boundary. For decades, the solar system seemed to end there. After Pluto, there was only darkness. At least, that is how many people imagined it. But astronomers were beginning to suspect that Pluto was not alone. Beyond Neptune, there might be many icy objects orbiting the sun. A whole region of frozen bodies, ancient leftovers from the formation of the solar system. This idea would eventually become known as the Kuiper Belt, and once astronomers started finding more objects in that region, Pluto's story began to change. At first, this did not seem dangerous for Pluto. Finding more objects beyond Neptune made Pluto more interesting. It meant Pluto was not a lonely accident. It was part of something larger, a frozen frontier filled with ancient material. But slowly, the discoveries raised an uncomfortable question. If Pluto was a planet, what about the other objects like it? In the 1990s and early 2000s, more and more icy bodies were discovered beyond Neptune. Some were small, some were strange, some had orbits similar to Pluto's. The outer solar system was no longer empty. It was crowded with frozen worlds. Then came the object that changed everything: Eris. Discovered in 2005, Eris appeared to be similar in size to Pluto, and at first it was thought it might even be slightly larger. It was farther away, icy, and part of the same broad distant population. If Pluto was the 9th planet, then was Eris the 10th? And if Eris was a planet, what about other large icy worlds? How many planets did the solar system really have? 10, 12, 20, hundreds? The problem was not that Pluto became less interesting. The problem was that the word planet had never been defined clearly enough. For most of history, people recognized planets by appearance and tradition. The ancient planets were moving lights in the sky. Later, Uranus and Neptune were added through telescopic discovery. Pluto joined as the distant ninth. But now astronomy had grown sharper. The solar system was no longer a neat list of 9. It was a complicated structure: rocky planets, gas giants, ice giants, asteroids, comets, moons, dwarf worlds, Kuiper Belt objects, scattered disk objects, a whole architecture of bodies orbiting the Sun. Pluto had entered the planetary family before we fully understood its neighborhood. Once that neighborhood became visible, its identity became harder to defend in the old way. But the emotional weight remained. To scientists, Pluto was a classification problem. To the public, Pluto was childhood. That is why the coming decision would hurt. Because the debate was never only about astronomy. It was about memory. It was about the feeling of losing something familiar. For 76 years, Pluto had stood at the end of the list. The final planet, the small frozen companion at the edge of the known solar system. People had grown up with it. Teachers had taught it. Children had drawn it. Planetariums had included it. Textbooks had printed it. And then science did what science always does. It changed when new evidence arrived. That is both the beauty and the pain of science. It does not protect our feelings from reality. It does not keep old categories just because they are beloved. When new discoveries force a better definition, the definition must change. But nobody could have imagined how emotional that change would become. In 2006, astronomers gathered at the International Astronomical Union meeting in Prague. The question was simple on the surface, but enormous underneath. What is a planet? The answer would decide Pluto's fate. And on August 24, 2006, the vote came. Pluto did not meet the new definition of a planet. It became a dwarf planet, a new category, a real world, a fascinating world, but not the 9th planet anymore. For many people, it felt like Pluto had been killed. Of course, Pluto itself did not change. It kept orbiting the Sun. It kept its icy mountains, frozen plains, thin atmosphere, moons, and mysteries. It did not know what humans had voted. It did not care what name we used. Out there in the darkness, nothing physical happened to Pluto on that day. No explosion, no disappearance, no cosmic funeral, only a word changed. But sometimes words matter. Planet, dwarf planet. The difference was enough to make millions of people feel that something had been taken away. The little world at the edge of the solar system had lost its place in the family portrait. And yet, in another way, Pluto was not killed at all. It was transformed, because the loss of its planet status forced humanity to look beyond the simple 9-planet story. It opened the door to the Kuiper Belt, to Eris, to Haumea, to Makemake, to thousands of icy bodies beyond Neptune, to a solar system far larger, stranger, and more crowded than the one many of us learned as children. Pluto's demotion was painful because it ended one story, but it began another, a deeper one, a messier one, a more truthful one. Still, before all of that, there was the old Pluto, the 9th planet, the final name in the rhyme, the distant world discovered by Clyde Tombaugh in 1930, the planet named by Venetia Burney, the small, cold world that became enormous in the human imagination, precisely because it was so far away, so alone, so mysterious. For 76 years, Pluto belonged to the planets. And then came the day everything changed. August 24th, 2006. The day the solar system was rewritten. The day the number 9 disappeared. The day Pluto was killed. The trouble began long before 2006. Pluto did not lose its title suddenly because of one meeting, one vote, or one argument in a room full of astronomers. The evidence had been building for decades, quietly, slowly, piece by piece. At first, Pluto looked like the final planet of the solar system because we did not yet know what else was hiding beyond Neptune. It was small, distant, and difficult to measure. It appeared as a faint point of light, moving slowly against the stars. And in 1930, that was enough. But as telescopes improved, Pluto began to look less like the ninth planet and more like the first clue to something much larger. The first warning sign was its size. When Pluto was discovered, astronomers did not know exactly how big it was. Because it was so far away and so faint, early estimates were uncertain. Some believed it might be close to Earth-sized. Others imagined it could be massive enough to explain tiny irregularities they thought they saw in the orbit of Neptune. That was one of the reasons people had searched for a ninth planet in the first place. The outer solar system seemed to be hiding something, a planet beyond Neptune, a world large enough to pull on the known planets, a missing piece. And when Pluto was found, it seemed like the answer. But then the estimates began to change. Pluto became smaller, then smaller again, and smaller again. As astronomers measured it more carefully, the imagined giant disappeared. Pluto was not Earth-sized, it was not even close. It was not a hidden massive planet shaping Neptune's orbit. It was a tiny frozen world at the edge of darkness. By the 1970s, after the discovery of Charon helped scientists measure Pluto's mass more accurately, the truth became impossible to ignore. Pluto was smaller than Earth's moon. That fact alone felt strange. A planet smaller than the moon, not smaller than Earth, not smaller than Mars, smaller than the object that circles our own planet every month. And it was not only smaller than the moon. Pluto is smaller than several moons in the solar system. Ganymede, Titan, Callisto, Io, Europa, Triton, and our moon are all larger than Pluto. That raised a quiet discomfort. How could something be a planet if so many moons were larger than it? Size alone does not decide everything. A world can be small and still important. Mercury is small compared with Earth, but Mercury dominates its orbit and behaves like a major planet. Pluto was different. It was not only small, it was small in a way that made astronomers wonder whether it had been placed in the wrong category from the beginning. Still, Pluto survived. People had already accepted it. It was the ninth planet. The smallest planet, yes. The strangest planet, yes, but still a planet. Then came the second warning sign. Pluto's orbit. The 8 major planets move around the Sun in relatively orderly paths. Their orbits are not perfect circles, but most are close enough to circular compared with Pluto. They also lie close to the same flat plane, called the ecliptic, the broad disk where the planets orbit. Pluto does not follow the pattern. Its orbit is highly elliptical, stretched, uneven. At its closest, Pluto comes much nearer to the Sun. At its farthest, it retreats deep into the dark. Its distance changes dramatically across its long orbit, making it feel less like a normal planet and more like a wandering icy body. Then, there is the tilt. Pluto's orbit is inclined by about 17 degrees from the ecliptic. That may not sound like much, but compared with the major planets, it is extreme. Most planets stay close to the same plane. Pluto rises above and dips below that plane, as if it belongs to another population of objects. And then there was the detail everyone remembered. Pluto crosses Neptune's orbit. For part of its path, Pluto is actually closer to the Sun than Neptune. Between 1979 and 1999, Neptune was the farthest known planet from the Sun, while Pluto moved inside Neptune's distance. This sounded wrong. A planet crossing the orbit of another planet felt untidy, dangerous, almost impossible. Of course, Pluto and Neptune are not going to collide. Their orbits are locked in a stable resonance. For every 2 orbits Pluto makes around the Sun, Neptune makes 3. This rhythm keeps them safely separated over long timescales. But emotionally, the problem remained. A real planet, people thought, should have a clean path. A planet should not move like this. It should not cross the territory of another major planet. It should not behave like a comet or a distant icy wanderer. Pluto's orbit was a warning written in geometry. The third warning sign was its composition. The solar system has a pattern. The inner planets are rocky. Mercury, Venus, Earth, and Mars, small, dense, made mostly of metal and rock. The outer giants are very different. Jupiter and Saturn are gas giants, huge worlds dominated by hydrogen and helium. Uranus and Neptune are ice giants made of hydrogen, helium, and heavier compounds like water, ammonia, and methane. Pluto did not fit either family. It was not a rocky inner planet. It was not a gas giant. It was not an ice giant. It was a mixture of rock and ice with a frozen surface made of nitrogen, methane, and carbon monoxide ices. Its density and composition made it feel closer to icy moons and Kuiper Belt objects than to the traditional planets. It was not only far away, it was a different kind of world. And that mattered, because classification is not just about emotion. It is about patterns. Scientists do not only ask what an object is, they ask what family it belongs to, what formed it, what shaped it, what other objects share its properties. Pluto was looking less like the final member of the planet family and more like the largest known member of a hidden icy population. But for a long time, that population was theoretical. Astronomers suspected there might be objects beyond Neptune, leftovers from the formation of the solar system, a frozen belt of small bodies orbiting in the darkness. But until the 1990s, Pluto remained the only clearly known world of its kind. That changed in 1992. Astronomers discovered an object called 1992 QB1. It was not a planet. It was small, faint, distant, and icy. But it was beyond Neptune. And it was real. That discovery opened a door. For the first time since Pluto and Charon, astronomers had found another object in the region beyond Neptune. It confirmed that Pluto was not alone. The outer solar system was not empty after all. There was a belt, a vast frozen wilderness beyond Neptune, the Kuiper Belt. And once astronomers knew how to look, more objects began to appear, then more and more. Each discovery changed Pluto a little. Not physically, Pluto itself remained the same frozen world it had always been. But its meaning changed. Before the Kuiper Belt, Pluto was the lonely 9th planet. After the Kuiper Belt, Pluto became part of a crown. That was the most devastating warning sign, because Pluto's uniqueness had protected it. It was small, but unique. Its orbit was strange, but unique. Its composition was icy, but unique. Its distance was extreme, but unique. But the Kuiper Belt removed that protection. Pluto was no longer a strange exception. It was one object among many. A large one, a fascinating one, a beautiful one, but not alone. The more Kuiper Belt objects astronomers discovered, the harder the old definition became to defend. Some of these bodies had orbits that resembled Pluto. Some were icy. Some were reddish. Some were trapped in resonances with Neptune. Some had moons. Some were part of a scattered population stretching far beyond the classical belt. The solar system had grown more complicated than the 9-planet diagram. And with every new frozen object, the same uncomfortable question returned. If Pluto is a planet, what about this one? And this one? And this one? At first, the question could be ignored. The new objects were much smaller than Pluto, so Pluto remained special enough. It could still be called the ninth planet, while the others were simply minor bodies. But the discoveries did not stop. The Kuiper Belt kept giving up larger objects: Quell, Sedna, Orcus, Haumea, Makemake, strange names for strange worlds. Each one made the old solar system feel less complete and more like an unfinished map. Then came the object that doomed Pluto's old identity more than anything else: Eris. Discovered in 2005 by Mike Brown and his team, Eris was distant, icy, and massive. At first, it appeared it might be larger than Pluto. Later measurements showed that Pluto is slightly larger in diameter, while Eris is actually more massive. But in 2005, the message was clear enough. Pluto had a rival. Not a tiny rock, not a minor speck, a world large enough to challenge the ninth planet. Eris orbited even farther from the Sun, in a distant region connected to the scattered disk. It was cold, remote, and bright enough to be noticed from Earth. And it had a moon, later named Dysnomia. This was the breaking point, because if Pluto was a planet, then Eris had to be one too. And if Eris was the 10th planet, then what about the others? Would Haumea become a planet? Would Makemake? Would Quell? Would Sedna? How many planets would children need to memorize? 10, 12, 20, 50? The questions sounded funny at first, but scientifically it was serious. The word planet could no longer survive on tradition alone. Astronomers needed a definition. Not because they hated Pluto, not because they wanted to remove something beloved, but because discoveries had made the old category unstable. Pluto had been accepted as a planet when it seemed alone. But once the Kuiper Belt was revealed, Pluto looked like one member of a wider family. And if every large icy body beyond Neptune became a planet, the solar system would no longer have a clean planet category. It would have a growing list of worlds with no clear boundary. This is where the emotional story and scientific story began to separate. To the public, Pluto was the ninth planet. To astronomers, Pluto was becoming a classification problem. And the problem was not Pluto's beauty or value. The problem was consistency. Science cannot simply say, "This object is a planet because we love it." It needs rules. And the rules had to work not only for Pluto, but for everything else being discovered beyond Neptune. In a way, Pluto was a victim of better knowledge. When it was discovered, we knew too little to understand what it really was. By 2006, we knew more. And knowing more changed the category. This happens often in science. A thing is named before it is fully understood. Then new evidence arrives. The name becomes uncomfortable, the category shifts, the story becomes more complex. Pluto was not demoted because it became less interesting. It was demoted because the solar system became more interesting. The discovery of the Kuiper Belt did not shrink Pluto. It expanded the neighborhood around it. It revealed that the edge of the solar system was not a lonely emptiness with one final planet, but a deep frozen region filled with ancient leftovers, dwarf worlds, icy bodies, and strange orbits. Pluto was no longer the end. It was the beginning of a frontier. But that truth came at a cost. The old picture had to die. The neat list of 9 planets had to be questioned. The mnemonic about 9 pizzas had to lose its last word. Textbooks had to be rewritten. Classrooms had to change. Planetarium posters had to be updated. And millions of people had to accept that the little world they had grown up with was not what they had been told it was. That is why the evidence felt almost like a trial. Pluto's small size, its strange orbit, its icy composition, its place inside the Kuiper Belt. And finally, Eris, the rival world that made the contradiction impossible to ignore. Each piece alone might not have killed Pluto's planetary title. Together, they formed the case. A planet smaller than the Moon could maybe survive. A planet with a tilted orbit could maybe survive. A planet made of ice and rock could maybe survive. A planet surrounded by similar bodies became harder to defend. But a planet with a near-equal rival beyond Neptune created a question that had to be answered. Either the solar system had many more planets, or Pluto was something else. That was the door Eris opened. And once it opened, it could never be closed again. Because the issue was no longer only Pluto. It was the meaning of the word planet. For 76 years, Pluto had lived inside a category built partly by tradition, partly by limited knowledge, and partly by human affection. But the outer solar system had finally revealed itself. It was not a clean border. It was not empty. It was full of frozen worlds. And Pluto, beloved as it was, belonged to them. The evidence had gathered quietly for decades. By 2006, the decision was no longer a surprise to many astronomers. It was the conclusion of a long discomfort, a discomfort that began when Pluto's size shrank, deepened when its orbit looked wrong, grew stronger when its composition seemed different, became serious when the Kuiper Belt appeared, and became unavoidable when Eris entered the story. Pluto was still real, still beautiful, still mysterious, still worthy of exploration. But the old title was no longer safe. The ninth planet was standing on evidence that had slowly cracked beneath it. And the final vote was coming. In August 2006, the fate of Pluto was decided in a conference hall in Prague. Not by an asteroid, not by a spacecraft, not by some new photograph that showed Pluto breaking apart in the darkness, but by a vote made by astronomers, a vote about language, a vote about what the word planet should mean. And somehow, that one decision changed the solar system that millions of people thought they knew. The International Astronomical Union had gathered in the Czech Republic for its General Assembly. Astronomers from around the world came together to discuss stars, galaxies, planets, discoveries, definitions, and the growing confusion at the edge of the solar system. But one question hung over everything. What do we do about Pluto? For years, the problem had been growing. Pluto was small. Its orbit was strange. It was icy. It belonged to a region filled with similar bodies. And then Eris had appeared, a distant world massive enough to challenge Pluto's place. The old solar system could not ignore the question anymore. Either Pluto remained a planet, and many other worlds might have to join it, or Pluto had to be moved into a new category. There was no painless answer, because this was not just a scientific debate, it was a debate about memory. For astronomers, the issue was classification. For the public, it was childhood. Pluto was not just a dot beyond Neptune. It was the ninth planet. It was the last word in the list. It was the lonely little world at the edge of the Sun's family. And now, in Prague, its title was on trial. At first, one proposal tried to save Pluto by expanding the definition of a planet. Under that idea, a planet would be any object that orbited the Sun and was massive enough for its own gravity to pull it into a nearly round shape. This would have kept Pluto as a planet, but it would not have kept the solar system at 9. It would have opened the door. Eris would become a planet. Ceres, the largest object in the asteroid belt, would become a planet again after losing that status long ago. Even Charon, Pluto's enormous moon, might have been considered part of a double-planet system, because Pluto and Charon orbit a point in space between them. And that was only the beginning. As telescopes improved, more round icy worlds would almost certainly be discovered beyond Neptune. The list of planets might grow from 9 to 12, then 20, then perhaps dozens, maybe one day hundreds. The solar system would no longer be the clean family people had memorized. It would become crowded, complex, and constantly changing. For some astronomers, that was fine. If nature gives us many planets, they argued, then we should accept many planets. The universe does not have to stay simple for human comfort. But others disagreed. They felt that the word planet should mean something more than being round and orbiting the sun. A planet should dominate its region. It should be gravitationally important in its own orbital neighborhood. It should not simply be one object among many similar objects in a belt. By that logic, Earth is clearly a planet because Earth controls its orbital zone. Jupiter is clearly a planet because it dominates the space around its path. Neptune is clearly a planet because it is the major gravitational body in its region. But Pluto does not dominate the Kuiper Belt. It lives inside it. It is part of a population, a large and important part, but still one member of a wider family of icy worlds. That difference became central. And so a second proposal emerged. Keep the 8 classical planets as planets. Create a new category for Pluto and worlds like it. Dwarf planets. Under this definition, Pluto would not be erased. It would not become an asteroid. It would not become meaningless. It would still be recognized as a real, round, complex world orbiting the sun. But it would no longer be the 9th planet. It would join Eris and Ceres in a new class, a class for objects that are round, important, and fascinating, but that have not cleared their orbital neighborhoods. This phrase, cleared its orbit, became the dividing line. A planet must orbit the sun. A planet must be round because of its own gravity. And a planet must have cleared the neighborhood around its orbit. Pluto failed the 3rd test, not because it was too small in a simple way, not because it was not beautiful, not because scientists disliked it, but because Pluto shares its orbital region with countless other Kuiper Belt objects. It does not gravitationally rule that zone the way the 8 major planets rule theirs. In the language of the new definition, Pluto was not a planet. It was a dwarf planet. The debate was intense. Some astronomers felt the new definition was too narrow. Some thought the vote was rushed. Some disliked the cleared orbit requirement. Some believed a geophysical definition would be better, one based on what a world is, not where it lives. Because if Pluto is round, geologically active, layered, icy, atmospheric, and complex, why should it matter that other icy bodies share its region? That argument still exists today. Many planetary scientists still call Pluto a planet in a geophysical sense, especially after New Horizons revealed how extraordinary Pluto truly is. But in 2006, the official definition moved in another direction. And then came the vote. This is one of the reasons the decision remains controversial. Thousands of astronomers had attended the General Assembly, and the International Astronomical Union had many thousands of members worldwide. But only a few hundred were present for the final vote. Only 424 astronomers voted on the resolution that changed Pluto's status, a tiny fraction of the global astronomical community, and yet that vote became official. Proposal 2 passed. The solar system went from 9 planets to 8 in a single afternoon. Pluto was reclassified as a dwarf planet. After 76 years, the 9th planet was gone. Not physically. Pluto still moved through space exactly as before. It still orbited the sun every 248 years. It still had Charon beside it. It still carried ice, mountains, plains, darkness, and secrets. But in human language, its place had changed. And the reaction was immediate. People were angry. confused, sad. Some laughed at the decision. Some rejected it completely. Some felt betrayed by science itself, as if astronomers had taken away a piece of childhood. Children asked why Pluto was not a planet anymore. Teachers had to change classroom posters. Textbooks became outdated. Planetariums updated their shows. The old mnemonic no longer worked. My very educated mother just served us 9 pizzas, suddenly had no pizza. The final word had disappeared. And that small change carried an emotional weight nobody expected. Because Pluto had never been powerful because of size. It was powerful because of meaning. It was the small one, the far one, the underdog, the cold little world at the end of the map. People loved Pluto precisely because it seemed fragile compared with the giants. It was not Jupiter with its storms, or Saturn with its rings, or Mars with its red deserts. Pluto was a faint frozen world, almost too distant to imagine. And now, that world had been told it did not belong. Across the world, people protested in their own ways. Petitions appeared demanding Pluto's reinstatement. Public campaigns defended the 9th planet. Cartoons showed Pluto being pushed out of the solar system family. T-shirts appeared with slogans supporting it. Even governments joined the emotion. In New Mexico, where Clyde Tombaugh had lived and worked, lawmakers symbolically honored Pluto as a planet. It was a gesture of loyalty to the man who discovered it at Lowell Observatory. Illinois, Tombaugh's birth state, also pushed back symbolically, declaring support for Pluto and criticizing the demotion. Of course, state legislatures cannot decide the scientific classification of celestial bodies. A law on Earth cannot change what Pluto is. But those symbolic acts showed something important. Pluto had become more than astronomy. It had become culture. A scientific decision had turned into a public mourning. And in some ways, that reaction revealed how deeply people care about the sky. We like to think of science as cold facts, numbers, definitions, and measurements. But the objects science studies often become part of human identity. Stars guide myths. Planets shape calendars. The moon shapes poetry. Mars becomes a dream of exploration. Saturn becomes beauty. Earth becomes home. And Pluto became the little world people wanted to protect. So when the official definition changed, many people did not hear, Pluto has been reclassified. They heard, Pluto has been rejected. But scientists did not kill Pluto. They changed the map. And that is where the story becomes more complicated. Because the demotion was painful, but it also revealed a deeper truth. The old solar system was too simple. 9 planets sounded complete, but it was not the full reality. Beyond Neptune, there was not emptiness. There was a frozen frontier, the Kuiper Belt, thousands of icy objects, dwarf planets, comets, ancient leftovers from the birth of the sun, worlds that had waited billions of years in darkness. Pluto was not the final planet. It was the first famous member of that hidden region. In that sense, the 2006 decision did not make Pluto smaller. It made the solar system larger. It told us that the edge of our planetary neighborhood was not a clean border, but a wilderness. A deep, cold, complicated wilderness filled with objects that do not fit neatly into the old categories. Still, the word mattered. For most people, dwarf planets sounded like a downgrade, a consolation prize, something less real. But that is not scientifically fair. A dwarf planet can still be extraordinary. Ceres may hold water-rich minerals and clues to the early solar system. Eris is massive, distant, and mysterious. Haumea spins so fast, it is stretched into an elongated shape. Makemake has its own frozen story, and Pluto, as we would later learn, is one of the most complex small worlds ever visited. But in 2006, Before New Horizons arrived, Pluto's true face was still unknown. People were arguing about a world they had never seen clearly. That is the irony. The vote came before the revelation. The reclassification happened in 2006. New Horizons would not reach Pluto until 2050. So when Pluto lost its title, humanity still pictured it mostly as a blurry, distant dot. No one yet knew about Sputnik Planitia, the giant heart-shaped plain of nitrogen ice. No one had seen mountains of water ice rising like frozen rock. No one had watched Pluto's thin blue haze wrapping around the planet. No one had seen evidence of geological activity, glaciers, strange terrains, possible internal oceans, and a world far more alive than expected. The world was demoted before it had the chance to show us who it really was. That made the story even more emotional later, because when New Horizons finally arrived, Pluto looked nothing like a dead little ice ball. It looked magnificent. But in Prague in 2006, the decision was made based on classification, not romance. The solar system needed a definition. The Kuiper Belt had changed the context. Eris had forced the issue, and astronomers chose 8 planets. This decision remains debated, and that debate is healthy. Some people argue the EAO definition is flawed because it applies only to objects orbiting the Sun, not exoplanets orbiting other stars. Others argue that clearing the orbit depends partly on distance from the Sun, because farther objects need more time and more mass to clear their zones. Others prefer a definition based on physical nature. If an object is round and geologically complex, it should be a planet. Under that view, Pluto is still a planet. So are many moons, dwarf planets, and large icy worlds. But officially, according to the EAO definition adopted in 2006, Pluto is a dwarf planet. The conflict between those views has never fully disappeared, and maybe that is fitting, because Pluto has always been difficult to classify. Too small for the old planet family, too complex to be dismissed, too beloved to be forgotten, too important to ignore. The decision in Prague did not end Pluto's story. It created a new one, a story about what science does when nature refuses to be simple. A story about how definitions can change when discoveries multiply. A story about how humans attach emotion to distant worlds. A story about a tiny frozen body that became the center of a debate about the entire solar system. And maybe that is why people still talk about the day Pluto was killed. Because it was not really about losing a planet. It was about losing the illusion that the solar system was simple. Before 2006, many people imagined a neat order: 9 planets, a list, a family, a final edge. After 2006, the picture became stranger. 8 major planets, dwarf planets, Kuiper Belt objects, scattered disk worlds, icy bodies beyond Neptune, a solar system with no clean ending. Pluto did not vanish, the boundary did, and that is far more unsettling. In one afternoon, the solar system changed from a familiar classroom diagram into a living scientific mystery, a place where categories can break, where beloved worlds can be renamed, where new discoveries force old truths to bend, and where a small frozen object, smaller than our moon, can make the entire planet Earth argue about what it means to be a planet. August 24th, 2006 became the day millions mourned Pluto, but it was also the day the solar system grew up. The day astronomy admitted that the old map was not enough. The day the 9th planet became the first symbol of something larger. And somewhere far beyond Neptune, Pluto kept moving, silent, unchanged, unbothered by the vote, still circling the sun in the dark, still carrying the same ice, the same mountains, the same moons, the same secrets. Humans had changed its title, but Pluto remained what it had always been: a world. New Horizons left Earth on January 19, 2006. At the time, Pluto was still officially the 9th planet. That detail feels almost poetic now. A spacecraft was launched toward Pluto, while Pluto still carried the title that generations had learned in school. The mission had been designed to visit the final planet, the distant world at the edge of the old solar system, the tiny frozen body that no spacecraft had ever seen up close. And then, only months later, Pluto was demoted. The spacecraft was already on its way. It was racing outward through the solar system, faster than any spacecraft ever launched at the time, carrying instruments, cameras, and even a small portion of Clyde Tombaugh's ashes toward the world he had discovered. But back on Earth, Pluto's name had changed. Not its physical nature, not its orbit, not its surface, only its category. The 9th planet had become a dwarf planet, and for 9 long years, New Horizons kept going. Past the orbit of Mars, past Jupiter, where it used the giant planet's gravity to increase its speed, past Saturn's distance, past Uranus, past Neptune, into the cold region where sunlight is weak and the sun becomes a brilliant point in the distance. For most of that journey, Pluto was still just a dot, a target, a promise, a place too small and too far away to reveal its face. Even the Hubble Space Telescope could only show rough patches of light and dark on its surface. We knew Pluto was real. We knew it had moons. We knew it had ice. We knew it was cold, distant, and strange. But we did not know Pluto. Not yet. Then, in 2015, the dot began to grow. Slowly, New Horizons images became sharper. Pluto changed from a blurred point into a small disk. Then the disk began showing markings, bright areas, dark areas, a pattern no one had ever seen clearly before. And then the heart appeared. A bright, enormous, heart-shaped region on Pluto's surface. It was later named Tombaugh Regio, honoring Clyde Tombaugh, the young astronomer who had found Pluto in 1930. That image changed everything emotionally. The world that had been demoted, debated, laughed about, defended, and mourned suddenly looked back at us with a heart on its surface. It was almost impossible not to feel something. Science does not depend on poetry, but sometimes the universe delivers poetry anyway. On July 14, 2015, New Horizons flew past Pluto. After more than 9 years of travel, after crossing billions of kilometers, after reaching a world no human spacecraft had ever visited, it passed through the Pluto system at incredible speed. It could not stop. It was not an orbiter. It was a flyby mission, moving too fast to enter orbit. For a brief window of time, New Horizons gathered as much data as it could: images, composition maps, atmospheric measurements, temperature readings, moon observations, surface details. Then it continued onward into the Kuiper Belt. But the data it sent back to Earth rewrote Pluto, because Pluto was not the dead, boring ice ball many people had expected. It was alive in the geological sense, not alive with biology, not alive with forests or oceans on the surface, but active, complex, young in places, layered, changing. A world with mountains, plains, glaciers, atmosphere, haze, possible cryovolcanoes, and signs of internal heat. The demoted planet turned out to be one of the most fascinating worlds ever explored. The most famous feature was the heart. Tombaugh Regio is not just a bright patch. Its western lobe, called Sputnik Planitia, is a vast plain of nitrogen ice. It stretches across the surface like a frozen sea, smooth, bright, and almost completely free of impact craters. That lack of craters was shocking on old, inactive worlds. Craters accumulate over time. Asteroids and icy debris strike the surface, leaving scars that can remain for billions of years. A heavily cratered surface is usually ancient. A smooth surface suggests something has erased the scars. On Pluto, Sputnik Planitia looked young. Very young, geologically speaking. The nitrogen ice was not simply sitting there like a dead frozen layer. It appeared to be moving. Slowly, deeply, quietly, scientists saw polygon-shaped patterns across the plane like giant cells. These are believed to be convection cells, where warmer nitrogen ice slowly rises, spreads, cools, and sinks again. This is not motion you could watch with your eyes. It happens over long timescales. But it means Pluto's surface is not frozen in permanent stillness. The ice is churning. A dwarf planet at the edge of the solar system has glaciers of nitrogen ice slowly moving across its surface. That single discovery was enough to change how people thought about Pluto. A world so small, so cold, and so far from the sun should have been dead. But it was not. Then came the mountains. New Horizons revealed mountains rising thousands of meters above Pluto's surface. Some are around 3,500 meters high. On Earth, mountains are made of rock. On Pluto, ordinary rock would be hidden deep below, and the surface is dominated by volatile ices like nitrogen, methane, and carbon monoxide. But those soft ices cannot build tall mountains. Nitrogen ice is too weak under Pluto's conditions, so the mountains are probably made of water ice. On Pluto, water ice is not like snow. It is more like bedrock. At those temperatures, water ice becomes hard and strong enough to form mountains. A substance that melts in your hand on Earth becomes the stone of Pluto. That is one of the strangest reversals in planetary science. On Earth, water flows. On Pluto, water builds mountains. And these mountains are not tiny hills. They can rise higher than many mountain ranges on Earth. On a small, icy world with weak gravity, frozen water can stand like rock beneath a black sky. The images showed rugged terrain, cliffs, ridges, smooth plains, dark regions, bright regions, and landscapes so varied that scientists struggled to explain them all at once. Pluto was not a simple ball of ice. It was a world. Then New Horizons looked at the atmosphere. Pluto has a thin atmosphere made mostly of nitrogen, with methane and carbon monoxide. It is delicate, faint, and constantly affected by the planet's long seasons and distance from the sun. Before the flyby, scientists knew Pluto had an atmosphere, but no one expected it to look quite the way it did. New Horizons saw layers of haze surrounding the planet, beautiful, thin blue haze. The blue color comes from the way small particles scatter sunlight. High in Pluto's atmosphere, ultraviolet light interacts with methane and other molecules, creating complex organic particles called tholins. These particles eventually drift downward, helping color parts of Pluto's surface reddish-brown. But in the atmosphere, they scatter blue light, blue haze around Pluto. A world so distant that sunlight is weak still has a glowing atmospheric edge, layered and delicate, wrapped around it like a ghostly shell. For people who had imagined Pluto as dead darkness, this was astonishing. There is something deeply strange about the phrase blue sky on Pluto. It is not blue like Earth's sky. It is not thick, warm, or breathable. No human could stand there without a spacesuit. But above that frozen surface, sunlight filters through haze and scatters into blue. A thin, fragile atmospheric glow exists over a world once dismissed as too small to matter. Again, Pluto refused to be simple. The contrast across its surface was just as powerful. Some regions are old and heavily cratered, preserving the record of ancient impacts. Other regions are young, fresh, smooth, and almost crater-free. That means Pluto's surface is not one age. It is a mixture of deep time and recent activity. One side remembers billions of years. Another side has been renewed. This is the kind of complexity scientists usually associate with larger worlds. Mars has ancient terrains and younger volcanic plains. Earth constantly renews itself. Icy moons like Europa and Enceladus show activity because of tidal forces from giant planets. But Pluto is small. Pluto orbits far from the Sun. Pluto is not being strongly needed by a nearby giant planet the way some icy moons are. So why is it active? That question remains one of the great surprises of the New Horizons mission. Some of the answer may lie in Sputnik Planitia itself. The basin may be deep, filled with nitrogen ice, and involved in the planet's thermal and rotational history. The weight of that ice may even have affected Pluto's orientation over time. Some of the answer may lie in internal heat. Even small worlds can retain heat from radioactive decay in their interiors. If Pluto has enough internal warmth, and if its outer shell is insulated well enough, it may maintain a subsurface ocean beneath the ice. A hidden ocean beneath Pluto. That idea would once have sounded almost impossible, but after New Horizons, it became serious. There are clues that Pluto may have a subsurface ocean, or may have had one for much of its history. The surface geology, the behavior of Sputnik Planitia, the apparent lack of global contraction features, and models of Pluto's interior all raise the possibility that liquid water may exist deep below the frozen crust. If true, Pluto is not only a dwarf planet, it is a potential ocean world. Not an ocean open to the sky, not a sea of waves under sunlight, but a dark internal ocean, buried beneath ice, warmed by the slow heat of the interior, hidden at the edge of the solar system. This is not proof of life. It is not even proof that the ocean definitely exists today. But the possibility alone is extraordinary, because it means that even far beyond Neptune, small icy worlds may be more active, more layered, and more geologically alive than we imagined. Pluto also showed possible evidence of cryovolcanism. Cryovolcanoes are ice volcanoes. Instead of erupting molten rock, they may erupt water, ammonia, methane, nitrogen, or slushy mixtures of volatile materials. On Pluto, features like Reitmons and Picardmons have been studied as possible cryovolcanic structures. They are huge, strange, mountain-like, with central depressions that make them look almost volcanic in shape. If they truly are cryovolcanoes, then Pluto once pushed material from its interior onto its surface, not lava but icy mixtures rising from below, reshaping the landscape in the cold darkness. Again, the message was the same. Pluto is not dead. It has geology, it has movement, it has atmosphere, it has weathering by ice, it has surface renewal, it may have internal liquid, it may have ice volcanoes, it has moons and a complex system around it. This was the cruelest timing in astronomical history. Pluto was demoted in 2006, then revealed as extraordinary in 2015. For 9 years, people argued about what Pluto was before anyone had truly seen it. And when the images finally came back, they made the demotion feel emotionally wrong to many people. Not because the EAO definition had magically changed. Under that definition, Pluto still had not cleared its orbit. It still belonged to the Kuiper Belt. It was still officially a dwarf planet. But emotionally, the New Horizons data changed the debate, because Pluto no longer looked like a small leftover object that could be quietly moved into a lesser category. It looked like a full world, A world with character, a world with landscapes, a world with surprises, a world that forced scientists to ask new questions. And that raised the uncomfortable question: what if we had waited? What if the vote had happened after New Horizons? What if astronomers had seen the heart, the mountains, the blue haze, the glaciers, and the possible cryovolcanoes before deciding Pluto's status? Would the decision have been different? Maybe not officially. The planet definition was based on orbital dynamics, not surface complexity. New Horizons did not change Pluto's orbit. It did not make Pluto clear its neighborhood. It did not remove the Kuiper Belt objects around it, but it may have changed the emotional and scientific mood of the debate. It would have been harder to treat Pluto like a minor footnote after seeing what it actually was. It would have been harder to say, casually, Pluto is not a planet, while looking at a world with active nitrogen glaciers and mountains of water ice. This is why some scientists still object to the EO definition. They argue that a planet should be defined by what it is physically, not only by where it orbits. If a world is round, differentiated, geologically complex, and capable of active processes, then perhaps it deserves to be called a planet in a geophysical sense. Under that view, Pluto is absolutely a planet. So are some moons. So are other dwarf planets. The solar system becomes larger and richer, not smaller. But the official definition remains: Pluto is a dwarf planet. And maybe the tension between those two views is part of Pluto's power now. It lives between categories: officially demoted, scientifically elevated, culturally beloved, physically unchanged. The 2015 flyby did something no vote could undo. It gave Pluto a face. Before New Horizons, Pluto was mostly an idea, a point of light, a symbol, a name at the end of a list. After New Horizons, Pluto became a place. You could look at its surface and see regions. You could see the heart. You could see mountains casting shadows. You could see hazes above the limb. You could see smooth plains and cratered lands. You could imagine standing there in a spacesuit under a faint sun on a frozen plain where nitrogen ice slowly moves beneath your boots. You could imagine looking toward the horizon and seeing water ice mountains rising in the distance. You could imagine Charon hanging in the sky, huge and still, because Pluto and Charon are tidally locked together. You could imagine a world no longer abstract. That is what New Horizons gave us, not just data, intimacy. For the first time, humanity met Pluto, and Pluto was more than we deserved. The spacecraft also revealed Charon as a strange and fascinating world. Charon has canyons, cliffs, dark polar material, and evidence of a dramatic history. The smaller moons, Nix, Hydra, Kerberos, and Styx, added even more complexity to the Pluto system. Pluto was not a lonely dot. It was a small system of worlds, a miniature architecture at the edge of the solar system. And all of it existed in the Kuiper Belt, the frozen region that had helped cause Pluto's demotion in the first place. That is the irony. The Kuiper Belt took Pluto's planet title away. But it also made Pluto more important, because Pluto became our first close look at a Kuiper Belt world, a representative of a whole population of icy bodies beyond Neptune, a gateway to understanding the ancient leftovers of planet formation. New Horizons did not only visit a dwarf planet, it visited a frontier, and Pluto was the first face of that frontier. So, what is Pluto actually? It is not simply the ninth planet. It is not simply a rejected planet. It is not simply a dwarf planet in the emotional sense people sometimes use, as if dwarf means unimportant. Pluto is a complex icy world in the Kuiper Belt. It is a dwarf planet. It is a geologically active body. It is a possible ocean world. It is the center of a system of moons. It is a frozen archive of the outer solar system. It is the world that forced us to redefine planet. It is the world that proved small bodies can still be astonishing. That may be the deeper lesson. We wanted the solar system to be simple. Big planets matter. Small things are leftovers. But Pluto broke that idea. It showed that small worlds can have hearts. Literally, in its bright surface shape, and scientifically, in its hidden activity. A small world can have glaciers. A small world can have mountains. A small world can have atmosphere. A small world can have seasons. A small world can have possible oceans. A small world can change everything. The day Pluto was killed was really the day we admitted our old categories were too small. But the day New Horizons arrived was the day Pluto answered back. Not with anger, not with protest, but with beauty. Here is my heart. Here are my mountains. Here is my sky. Here is my moving ice. Here are my moons. Here is everything you did not know when you changed my name. That is why Pluto's story still hurts. It was demoted before it was understood, classified before it was seen, judged before it could reveal its complexity. And yet, maybe that makes its story more powerful. Because Pluto did not need the title to become extraordinary. It already was. The vote changed the word. The spacecraft revealed the world. And the world was magnificent. The debate over Pluto never truly ended. In 2006, the official decision was made. The International Astronomical Union voted, the definition changed, and Pluto became a dwarf planet. But science is not always as clean as a vote. A vote can create an official category. It can update textbooks. It can change classroom posters. It can force teachers to explain why the solar system no longer has 9 planets. But a vote does not always create agreement. And with Pluto, agreement never fully came. From the moment the decision was announced, many scientists pushed back. Not only the public, not only people who loved Pluto because they grew up with it. Actual planetary scientists, researchers who study worlds, surfaces, atmospheres, geology, moons, and planetary evolution, argued that the 2006 definition was flawed. Their argument was simple. Pluto was not less of a world because it shared its region with other icy bodies. Pluto was still round, still layered, still geologically active, still atmospheric, still complex, still the center of its own system of moons. So why should it stop being a planet? This is where the geophysical definition comes in. Under this alternative definition, a planet is any natural object in space large enough for its own gravity to pull it into a round shape, but not massive enough to become a star. In other words, if a world is big enough to become spherical because of its own gravity, then it has crossed an important physical threshold. It is no longer just an irregular rock. It is a world. Under that definition, Pluto is absolutely a planet. No hesitation, no debate. Pluto is round. It has geology. It has atmosphere. It has internal structure. It has moons. It has active surface processes. It behaves like a complex planetary body. But this definition would change the solar system completely, because Pluto would not return alone. Ceres would be a planet. Eris would be a planet. Haumea and Makemake would be planets. Large moons might also qualify as planets in a geophysical sense. Worlds like Europa, Ganymede, Titan, Triton, Enceladus, and our own moon. The number would not be 8. It would not be 9. It might be over 100. For many people, that sounds confusing. But to geophysical planet scientists, that is not a problem. If nature gives us more than 100 planets, then perhaps the mistake was never the number. Perhaps the mistake was thinking the solar system had to be simple. The old model was easy to memorize, but easy is not always true. The universe does not arrange itself for classroom posters. It does not care if children can memorize the list in one sentence. It builds worlds in categories that blur, overlap, and surprise us. The critics of the EO definition have been numerous and vocal for years. One of the strongest criticisms is that the official definition only applies to objects orbiting the Sun. That creates a strange problem. The galaxy is full of planets orbiting other stars. We call them exoplanets. We study them, classify them, compare them, and search their atmospheres for signs of life. But the YAO definition adopted in 2006 was written specifically for our solar system. That means, technically, it does not directly define the planets around other stars. For some scientists, this is deeply flawed. A definition of planet should work for planets everywhere, not only for objects orbiting our Sun. If a definition cannot easily classify most of the planets in the universe, then something about it feels incomplete. Another criticism is the idea of clearing the orbit. According to the EO definition, a planet must clear the neighborhood around its orbit. The 8 major planets have done this. Pluto has not. It lives among other Kuiper Belt objects. But clearing an orbit depends partly on where an object is located. The farther an object is from the Sun, the larger its orbital path, the slower it moves, and the harder it becomes to clear that region. A body at Pluto's distance would need far more time and mass to dominate its neighborhood than a similar body closer to the Sun. So critics ask, is this really measuring what a world is? Or is it measuring where a world happens to be? That question matters, because Pluto did not become less complex because of its neighborhood. It did not lose its mountains because Eris exists. It did not lose its atmosphere because the Kuiper Belt is crowded. It did not lose its heart-shaped plane because it shares a region with other icy bodies. The YAO definition classified Pluto by its orbital environment. The geophysical definition classifies Pluto by its physical nature. And those two approaches lead to different answers. Alan Stern, the lead scientist of the New Horizons mission, has never accepted the demotion. To him and many others, Pluto is a planet, not because of nostalgia, but because of what Pluto is as a physical world. Stern has also criticized the voting process itself. Only 424 astronomers voted in the final decision. That was a small fraction of YAO membership, and an even smaller fraction of the global scientific community. Many planetary scientists were not present for the final vote. Some opposed the process. Some felt the definition was rushed. Some never accepted that the matter had been truly settled. So yes, the definition passed. But the consensus never fully formed. That is important. People often speak as if the Pluto debate is finished, as if science made its final decision and everyone moved on. But that is not what happened. The argument continued. It still continues. And every new discovery about Pluto makes the question more complicated. Before New Horizons, Pluto could still be imagined by some as a small, frozen leftover. Interesting, yes, but perhaps not world-like enough to deserve the emotional defense people gave it. Then the spacecraft arrived, and Pluto became harder to dismiss. A heart-shaped plain of nitrogen ice, glaciers moving slowly across the surface, mountains made of water ice rising thousands of meters high. a thin atmosphere with layered haze, a blue glow around the planet, young terrain beside ancient cratered regions, possible cryovolcanoes, a possible subsurface ocean, a complex system of 5 moons. This was not a dead pebble. This was a living world in the geological sense, a world still changing, a world with internal processes, a world with landscapes that told stories, a world that looked, in many ways, more active and surprising than some places that kept more respected labels. That is why the debate became deeper after 2015. New Horizons did not change Pluto's official category. It did not make Pluto clear its orbit. It did not erase the Kuiper Belt. But it changed how Pluto felt. It changed the emotional and scientific weight of the object. When you look at Pluto's heart, it becomes much harder to think of it as merely a demoted object. When you see mountains on Pluto, you are reminded that small worlds can still be powerful. When you see evidence of a possible ocean beneath the crust, you realize that Pluto may belong in the same conversation as other complex ocean worlds. And when you see 5 moons orbiting around it, Pluto stops feeling like a lonely leftover and starts feeling like the center of a small planetary system. Charon alone makes Pluto extraordinary. It is so large compared with Pluto that the 2 bodies orbit a point in space outside Pluto itself. They are tightly locked, always showing the same faces to each other, turning together in the dark like a frozen double world. Then there are Nix, Hydra, Kerberos, and Styx, small moons moving through the Pluto system, each adding complexity to a world many people once imagined as simple. A planet does not need to be large to have a story. Pluto proves that. But the emotional argument cannot be ignored either. Some scientists dislike emotional arguments in classification, and that is understandable. Science should not decide categories only because people are attached to them. But emotions explain why this debate lasted. Generations grew up with 9 planets. The names were memorized like a ritual. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. That list became part of childhood, part of school, part of how people pictured their place in the solar system. Pluto was not only a word in a textbook, it was the final destination, the edge, the small lonely world that completed the family. When it was removed, many people felt as if something had been taken from them, not because they misunderstood science, but because science had touched memory. That is rare. Most classification decisions do not make the public angry. Few people protest changes in asteroid taxonomy. Few children cry when a distant object receives a new catalog number. But Pluto was different. Pluto had already entered the human heart. And maybe that is not a weakness. Maybe it shows that astronomy is not only about objects far away. It is about how we see ourselves inside the universe. The solar system is our cosmic neighborhood. Its planets are the landmarks of our imagination. Changing that map changes something in us. For some, Pluto's demotion felt like losing a member of the family. For others, it felt like science doing exactly what science should do, updating itself when new discoveries make old ideas too simple. Both feelings can be true. Science can be correct to change, and people can still mourn what changed. The honest scientific answer is this: the definition of planet is genuinely unsettled. Officially, Pluto is a dwarf planet, but scientifically, the deeper question remains open depending on which definition you use. If a planet is defined by orbital dominance, Pluto is not one. If a planet is defined by physical nature, Pluto is one. If you care about the architecture of the solar system, the Yao definition makes sense to many astronomers. If you care about geology, surfaces, atmospheres, and internal activity, the geophysical definition makes sense to many planetary scientists. The word planet carries more than one kind of meaning. That is why the 2006 vote settled less than people think. It created an official rule. It did not end the argument. It moved the argument forward. And maybe that is exactly what Pluto has always done. It forces us to ask better questions. When it was discovered, it made us ask what existed beyond Neptune. When its size shrank, it made us ask whether a planet had to be large. When the Kuiper Belt was discovered, it made us ask whether Pluto was alone. When Eris appeared, it made us ask how many planets the solar system should have. When the EAL voted, it made us ask what a planet even means. When New Horizons arrived, it made us ask whether our definitions were too narrow to capture the beauty of real worlds. Pluto's greatest gift may not be that it gave us a ninth planet. It may be that it broke our certainty. It reminded us that the solar system is not a neat diagram. It is a living scientific landscape full of objects that resist simple labels. Should Pluto be reinstated? The answer depends on what kind of truth you want the word planet to carry. If the word should describe the major bodies that dominate the architecture of the solar system, then Pluto remains a dwarf planet. If the word should describe complex round worlds with geology and internal evolution, then Pluto deserves to be called a planet again. And if we are honest, both sides are trying to protect something real. One side protects order, the other protects wonder. One side wants the category to remain useful and limited. The other wants the category to reflect the richness of planetary bodies. Pluto stands between them. Small enough to challenge the old list, complex enough to challenge its demotion. That is why Pluto will never be just another dwarf planet in the public imagination. It is the world that made us argue with ourselves, the world that turned classification into culture, the world that showed a title can be removed, but meaning can remain. Because no matter what any committee decides, Pluto remains what it always was: a world, a real place orbiting the sun, a cold, distant, active, beautiful world in the Kuiper Belt. It still has its heart-shaped plain of nitrogen ice. It still has mountains of frozen water. It still has blue atmospheric haze. It still has 5 moons. It still may have a hidden ocean beneath its crust. It still moves through the darkness, completing one orbit every 248 Earth years. It still carries the ashes of the man who discovered it, delivered by New Horizons into the outer solar system. It still inspires children who see its image for the first time. And perhaps that is what matters most, because labels are useful, but they are not the whole truth. A label helps us organize reality. It does not create reality. The word changed. The world did not. Tonight, as you drift to sleep, Pluto is still out there, far beyond Neptune, far beyond the bright warmth of Earth, still orbiting the sun in the deep cold, still moving with Charon beside it, the two worlds locked together in a slow frozen dance, still surrounded by Nix, Hydra, Kerberos, and Styx, still carrying its heart-shaped plane across the darkness, still holding mountains, glaciers, haze, and secrets beneath a sky almost unimaginably far from home. Nobody's vote changed what Pluto actually is. It is still active, still geological, still extraordinary. The label changed, the world did not. And somewhere tonight, a child is looking at a picture of Pluto's heart and falling in love with a world they may never visit, just as generations before them fell in love with the 9th planet. Some things cannot be demoted. Not really. no matter what anyone decides. Good night.